All right, everybody, it's Hugo Bown-Anderson and Eddie Mattia from Metaflow and Out of Bounds here. What's up, Eddie?
Not much, Hugo. How you doing?
I'm well. I'm actually incredibly excited to be teaching this or introducing this YouTube tutorial with you, this video tutorial. Today, we're actually going to be talking about LLMs and Gen AI in practice. So a guide to recent techniques and trends at Out of Bounds and Metaflow. Everybody, we work a lot in machine learning infrastructure, so building tools that help data scientists, MLEs, anyone working in, so that's machine learning engineers, anyone working in the data space, to do the modeling they love while having access to the infrastructure that they need. And a big part of that we're working on currently are LLMs and thinking about how to embed LLMs, foundation models, generative AI more generally in your pre-existing enterprise stacks, and moving from all the prototypes we see to actually having your foundation models in your pre-existing production systems. So we've been working on this stuff and we wanted to bring a bunch of it to you. So what we're going to do today is we're going to teach you about methods for working with LLMs. These stories are going to be guided by examples you can run on your laptop in our Metaflow sandbox. So that's a free hosted cloud environment provided to all of you. You can think of it as Google Colab for MLOps, if you will, but it's a lot more than that as well. We provide you the full stack of infrastructure, essentially, to play around with these things. As developers, you'll expand your awareness of how researchers and product designers are working with LLMs, with an emphasis on connecting high-level concepts such as fine-tuning foundation models and vector databases to the fundamental math and APIs data scientists should understand. I also think business-minded executives will get a bunch out of this, and you can get hands-on or follow the high-level stories to deepen your sense of what's possible with LLMs. I think the primary value of this workshop will be as a guide to help teams set reasonable goals in the complex and fast-moving world of large language models and understand what you need to successfully support your team's next LLM projects. Prerequisites are a basic knowledge of Python, ability to use the command line, and ability to use common machine learning algorithms in a notebook environment. But if you don't know those things and you have a willingness to learn and a curiosity, we always think that that's the most important prerequisite. Before we jump in, just a bit more about what you'll learn. There are lots of different ways to build on top of LLMs. There are, in the short term, cheap ways, such as using APIs. There are short-term, more expensive ways, such as fine-tuning and training your own. The methods you choose will have significant consequences in the software you can build and how your dev team works. We're going to learn to think about about these choices as we develop basic apps you can use as templates for future Gen AI projects. And as we said before, you'll have the option to follow along in our provided sandbox dev environment, where we'll unpack these choices and make the trade-offs and decision space concrete. Before jumping in, Eddie, is there anything you'd add to that? That was a lot to take in, everyone, but of course, over the next hour or two, we're going to, see this play out. Is there anything you'd add to that, Eduardo?
Just to get started, play around and tinker around with the stuff that we're going to show you. A lot of it is, sure, we're talking about enterprise infrastructure and fancy business terminology, but also a lot of it's just kind of messing around with your ChatGPT interface to get it to do what you want. And just understanding how these LLMs behave is probably, that's my advice, in all of this, is that's the most useful skill to make your own knowledge, to focus on your own knowledge and understanding how to use these systems.
Totally. Yeah. Play around, enjoy yourself, have fun, and create, build. So just want to confirm you can see my screen, Eddie?
Yeah, it looks good. I see the title slide right now.
Amazing. This beautiful data scientist reaping the fruits of everyone's work while being supported by a platform and infrastructure engineer down below. Great. So let's jump into thinking about LLMs and generative AI in practice. So just to motivate what we're talking about today, and we'll link to a talk given by our co-founder and CEO, Ville Toulos, at the San Francisco Exploratorium, actually, about these, that goes into more detail in the slides I'm about to present. But we're going to give a classic example of e-commerce. Now, this is one illustrative example. And of course, the types of things we're talking about extend to a lot of different spaces, but we thought to ground it in concreteness. So in 2014, if you were trying to buy a sofa online. You might have seen a website like this, and you'll click on something and go on through to purchase it. And this will probably interact with a database on the back end and execute some sort of SQL query and give you information and a result. And then, based upon that, right? So of course, there's a lot of like data engineering and then front end stuff that goes into this. But that's the basics of what would have happened 9 years ago. So what's happening now? What's happening differently there, Eddie? Now, do you think?
Oh, the pictures are definitely bigger for one.
Exactly.
Like different color schemes, you can kind of see things going from dark to light, like a lot of focus on design, aesthetics. Sure, lots of like fancy UI, UX research has gone into this.
Absolutely. But not a lot necessarily on the back end yet, right?
Yeah, but yeah, good point. It's still kind of like a grid of images that like you can see how this is pretty clearly connected to like that SQL way of storing your data backend system.
Exactly. But we do have maybe some sort of chatbot down here or customer service, so we have the beginnings of something along those lines. So the question then is, with all the generative AI stuff, how is this going to change? And so in the not too distant future, we're going to have a lot of different capabilities due to this, right? So now, what we're going to see soon is some sort of natural language interface which can interact with everything that's happened there. So I'm seeing a big room with a bunch of stuff I may like, but let's say I actually wanted a pink sofa instead. So I'd type that in, and then I'm actually going to see a pink sofa appear there, right? But let's say pink's cool, but let's say I actually wanted to try leather immediately and see what that looked like in real time. Then we'll have something along these lines. But of course, as we'll get to, the Gen AI isn't that good because it's like the 6 fingers on humans or whatever. We've got like these pillows in the background there, right? But that, all jokes aside, this is quite incredible. Let's say I wanted to find out more about this lamp. Then I'll get information about this lamp, perhaps some sort of influencer recommendation there. And so let's just unpack everything we've seen and happened there, because that looked maybe relatively straightforward, but there's actually in this not so distant future, there's a lot happening here. When I type something in there, I'm performing some sort of query with a large language model, right? Then when I clicked on this, there's an object recognizer and some sort of LLM creating a description there, then an influencer recommendation system. We've got image generation happening as well. And I made kind of a joke or a teasing aside around how, image generation doesn't quite get things right all the time, but I did a very good job in this case. And we also have personalized discovery, right? So what it's doing is making these types of interfaces essentially easier to use and more human-centric and more human-friendly. Is there anything you'd add to that, Eddie, before we move on?
Yeah, I think in addition to the human friendliness, like the generative word is like obviously becoming a buzzword, but it's so apt in this example of what the future might look like. With this couch that we're seeing here, unlike the SQL database grid of the website, this couch might not exist or might never have been produced before by any manufacturer. So that like somehow through the connection of like text to image generation, we're actually creating like a new real product that a company could get a signal if people are looking to buy. Now there's like obviously a question where like at some point that becomes like bad business to just like promise things you can't actually make and can't actually deliver on. But I think that that's a superpower for like actually figuring out what people want, doing personalized discovery, as you mentioned, and then even connecting it all the way down to these downstream things like detecting images within that detecting objects within that generated image and having an influencer recommendation appear associated with that object.
Yeah, absolutely. And then on top of that, as I said, this was an illustrative example, but like this will impact all types of things such as inventory forecasts, logistics, lifetime value optimization, causal marketing models, that type of stuff. So suddenly we've got all these things that we're including in our software now. And the question now is, wait a second, we have existing software stacks. How do we incorporate this type of stuff? And there's a lot of talk around prototype to production in the world currently. Not a lot of it is telling us much about prototype to production as far as I can tell. So we really want to attack that head on. And so the question is, how does this interact with the pre-existing stack, with all the data engineering challenges, all the data lakes, data warehouses, having things in Parquet shards, being on S3, in Snowflake, these types of things? How does this interact with the compute layer? If you're sending things to GPUs and you need CUDA drivers, or sending things to cloud resources on AWS, Azure, or GCP, how does this interact with your orchestration tools when you have complex workflows? Perhaps you have your data engineering workflows orchestrated with Airflow. Perhaps your machine learning workflows are orchestrated with Metaflow, which of course integrate with each other. How do you integrate all of these new things into your orchestration tools? How do you think about versioning here, right? How does that correspond with the experiment trackers you use? What changes with the deployment story here? And then how can we leverage this entire stack and have data scientists and machine learning engineers focus on the models that they love to build? So these are the types of questions that we're going to dive into today, or give a sense towards, and we'll provide further resources with respect to all the things you can look at in Metaflow that will help you think through this. So all of this really motivates why we even want to use something like Metaflow. So Metaflow, which was originally developed at Netflix in 2017 and open sourced in 2019, allows you to build systems and machine learning and AI systems, and not just models. So as I've really stated already, Metaflow allows you to interact with this entire stack as a data scientist or machine learning engineer while focusing on the top, on the modeling. And there's often a question, wait, why is data at the bottom of the stack? Don't data scientists really care about data? And yes, of course they do. They aren't necessarily so concerned with data in the infrastructural layer and in the infrastructural sense, in terms of all the data engineering that comes into play. Data scientists aren't too concerned about whether their data comes from Snowflake or a different place or an S3 file. They want to start an S3 bucket. They want to start working with their data and modeling it as soon as possible. So then how does this stack interoperate with LLMs and foundation models? I mean, one way to think about it is we have, and this is once again an illustrative example, but particularly in your organizations, you want to start thinking about where your governance boundary is, what you control and what you don't, essentially, in terms of the tools and models you use. If you have chatbots or products which require recommendation or whatever it may be, the example we just gave, you may have an open source foundation model which you don't govern, but then you bring it in and you fine tune it, you use it for embeddings and serve the results of these to a customer service chatbot. You may also have data coming from a data warehouse. These, along with the embeddings, going to personalize recommendations, then back into a warehouse, which are then used for your product. Similarly, you may have AI vendor APIs, which generate images. They get information from your data warehouse, then put them to cloud storage, and then they're directed into your product as well. So this is to give kind of one sense of the way things can work, but also to get you already thinking about the importance of your governance boundary, and also thinking through the ability to switch these things in and out. Let's say you're using DALL-E 3 to generate images here, and you decide the new version of Stable Diffusion is actually better for your needs. Ideally, you'd be able to swap these things in and out, and that's something which Metaflow affords as well, relative ease of switching interoperable components. So, as we've already really said, on the data layer, we need secure and fast connections to data warehouses and lakes. We need scalable compute with CPUs and GPUs. We need a dev-friendly API for building systems in the form of an orchestrator. A key part of that is being able to version all code, data, and models automatically, having access to that version stuff as well, then being able to deploy, and then being able to get the best models, and kind of closing this iterative loop between working locally in notebooks, for example, do all the basic science and figure out what models you may want to use, and then deploying to production and coming back. So what Metaflow provides is a common API for this robust, battle-hardened infrastructure, and you can see all types of things here. You can use scikit-learn or any Hugging Face models, etc., on the modeling layer. You can deploy with Argo step functions, version with Metaflow, orchestrate with Metaflow. If you're already doing data engineering orchestration with Airflow, as we said, we interoperate with that. And all your data and compute layers of choice, we allow you to plug and play there. And we'll get into examples of those very shortly. On top of that, of course, we can't forget about, key foundational operational concerns such as security, observability, and having kind of human-centric dev workflows. So what we're going to do is jump into the sandbox. There are lots of other lessons we have on our sandbox. We've got, recommendation system lessons, natural language processing, computer vision, among many others. A great one that Eddie worked on, which is a foundation model, the speech to text, OpenAI's Whisper, right, Eddie?
Yeah, totally good stuff.
And this is a catalog that's growing and growing. So I think, is that in the spirit of, talk a bit about the structure, and then I've been babbling on for far too long. So then we're gonna get in, and Eddie's gonna start showing us how to do all of this stuff. So part one, the easy way. Eddie, you're going to talk us through hitting large language model APIs, right?
Yep. Yeah. Like using OpenAI in Python code, and kind of like how you can change OpenAI, whether you use ChatGPT UI or whether you want to write your own Python notebooks or scripts that call the same model behind the scenes.
So good, man. And then in part two, tell us what's going to happen there.
In part two, we're going to kind of do the same thing, but we're going to use an open source model. So instead of calling it an API, we're going to actually like have the model itself living on our sandbox, and like kind of look at the PyTorch of it all, and like actually see what the model is on the computer, but kind of doing the same thing that we were doing in the first part with ChatGPT.
That's so cool, man. And what can you tease us with what the model is? What's the model?
We're going to actually use a whole bunch of them. So we're going to like kind of basically like look at what is Hugging Face really, which is like the distribution channel for most of these models in the open source community right now. So we're going to kind of understand like basically like what do you want to do like on a task level with Hugging Face, and then how do you go shop for models in the Hugging Face hub and pick one.
Amazing.
So one model we use is Bloom, but there's many of them, and we're going to go through like 3 or 4 of them throughout the workshop.
So cool. And I presume a lot of the viewers here know what Hugging Face is, but another way to put it is it's the wild west of machine learning models at the moment, right? I mean, it's an amazing, crazy space, hey?
Hundreds of thousands of models and data sets, and like many different things that you can just go point and click your way into finding.
Totally.
Downloads for many of them. It's really wild.
Oh, pardon me. So we've used our models and that type of stuff, but then wait, what's happening here? We're gonna have a ragathon?
We're gonna ragathon. We'll actually talk a little bit about prompt engineering, just kind of like the basics of what people even mean when they say that word. Like show you how to do it again in the ChatGPT UI, and then same thing in a notebook, and then kind of keep going in that direction of like make the LLM more relevant by giving it better data in how you talk to the LLM. So there's like certain ways that you can kind of like write that ChatGPT will just listen to you better, is the idea around all of this. And then of course RAG is like put your own data inside of that way that you write to ChatGPT.
That's so cool, man. And then we're going to productionize as well.
Yeah, so what we're talking about here, this is like the part where Metaflow comes in. So like all of our conversations around like workflows and kind of like more enterprise concerns. If you're going to do something like RAG, it's like one of the biggest reasons to do it is you want fresh data. And Metaflow has features that will help you do things like refresh and index, which if you're not familiar with that terminology, we'll go into that in the RAG sections. Basically, the idea is like you'll get to deploy in your sandbox workflows that run on a schedule, or when events happen in your cloud systems, and then something happens, it updates the pipeline that is what's feeding the LLM interactions that might be facing your end users, or might just be you talking in a notebook.
Super cool, man. And then to wrap up, we'll be fine tuning, right?
Yeah, so time permitting, maybe we'll do this in another lesson, we'll see, but we can at least walk through the code of like what is it like to actually now take one of these models that's open source, Llama 2 in this example from Meta AI, and then actually train it ourselves. So unlike RAG, where we're just kind of changing the input output that the model sees, we're actually here going to be taking the model itself, a 7 billion parameter Llama 2 model, and we're going to be training it, and specifically using a bunch of like kind of fancy optimization techniques called QLoRa, that have become trendy lately for people who are doing this in resource constrained environments. So yeah, the upshot here is we're like taking our own model, like we own the weights in this open source paradigm, and then we're gonna like see a little bit how to do that process of fine tuning and then serving the model ourselves. So this is much more like if we wanted to have an API, like the thing that we're using in these first lessons with ChatGPT in our notebook, but we actually want to own the whole supply chain is the idea there.
Amazing. Well, let's jump in and hit some OpenAI APIs. Do you want to share your screen?
Yeah, let's do it. Okay. Do you see my browser?
I do.
Now? Okay, cool. So this is actually the plug for the original airing of this workshop. So I should mention now that I'm on the screen, shout out to the MLOps World Conference where we originally prepared this workshop for. And actually the Generative AI Summit in particular was a new event. It's part of the MLOps Summit this year. And this is where we were presenting. So we created this GitHub repository, which you can all go to, and we'll share a link in the description for the video. And this has an explanation of how you can open up your Metaflow sandbox and then clone this repository, configure your sandbox, so all of the content will just load right into your sandbox. So I'm going to go ahead and follow these instructions, open the sandbox link, and then I'll just copy this command for later. This is one of the pages I think Hugo maybe mentioned earlier. There's a bunch of different workspaces that you can click on here in your free time, but we're actually not going to use any of them. We are just going to kind of airlift a new workspace into the sandbox using these instructions in the GitHub repository. Okay. Hugo, what are your thoughts on the sandbox? What should people who have never used it or don't know about what Metaflow is know about the sandbox?
I think they should know that there's, as we've kind of gone through, there's a huge stack of infrastructure required to actually do full stack productionized machine learning. You know, all the way from the data, the compute, all the way up to the modeling. Oh, pardon me. And so to actually get set up with all of that is highly non-trivial. So what we want to do is make sure that you can interact with the full stack of machine learning infrastructure as quickly as possible without having to do all that setup. So you can jump into the sandbox and go through these initial introduction to Metaflow and see how you can scale out to the cloud, access Kubernetes clusters, deploy things to production, A/B test models, these types of things.
Exactly. Very nice, very nice. Okay, so I've just followed through step 3, where now I've opened up into this Generative AI World Summit. Just going to do a refresh and get our nice outer bounds theme on the VS Code here.
And that's the other thing. If you haven't seen our sandbox before, you may recognize it's a browser-based, superpowered version of VS Code, essentially. And that doesn't even quite do it justice. But we'll see. So maybe talk people through what you're doing now, Eddie, just so people can code along.
So if you're following along, this is just a setup script. Nothing interesting going on, really. These red blinking lights are just to call your attention to the fact that there's a lot of stuff, as we've been mentioning, that is already in your sandbox. We like pre-install many things for you just to make it very easy to get started with these workspaces. However, in this workshop, we're going to be downloading some rather big models into the sandbox. And since these are free, they're not the most powerful computers. So we just want to make sure that you have enough space on your sandbox machine to actually run the examples if you want to follow.
And also,
along.
I mean, you just chose a kernel, so let's make sure people know what you did there.
Yeah, VS Code will prompt you when you try to run the first cell in each notebook here. And it'll prompt you and ask you to pick a kernel. So it should have the sandbox tutorial one by default. But that's the one that you want for this session is the sandbox tutorial. While that's loading, I'll actually show you something else about the sandbox that might be interesting to some of you. There are things personally that I don't like about VS Code. It's an excellent tool, but some people prefer a more classic Jupyter experience. Like, I think Hugo might be one of them. Correct me if I'm wrong. But one little in your sandbox is you can always just go here and everything after dev, you can type /Jupyter, and voila, you've got the full on kind of old school experience. I can click into my Gen AI Summit. And then if we want, I can kind of open up my notebooks from here and kind of do the thing that way if you choose.
Yeah, I'd push back on that. And so, I mean, I love Jupyter notebooks for exploration and doing notebooky stuff. But as we're talking about productionization, I'd encourage, I think I definitely do exploration in notebooks in VS Code, but when I'm deploying models to production, I write flows in scripts. And I think VS Code provides a wonderful interface for going back and forth between those two.
Yeah, totally. Although, I mean, I suppose to counter the counter, there is kind of the IDE feel of the Jupyter lab community.
Oh, so Jupyter Labs a totally different thing. Yeah.
Of course. Anyways, yeah, this thing should just take a minute or two to run. So this one's taking a little bit longer just because it's a brand new sandbox, but not a huge deal. We can actually also click around between cells or between these sections, excuse me, while that's running. So let me actually just get rid of this terminal.
And maybe show people as well that, we've got that nice out of bounds and Metaflow table of contents on the left, but everything to the left of that remains the same. So you've got your local file system, right, Eddie?
Yeah, exactly. Like this is the normal activity bar, as VS Code calls it in their application. So you can kind of get all the stuff that you want. Like if you want to try to install any special extensions, you want to use the debugger, they have the Git stuff is already like configured. And then of course, probably the most important one is being able to navigate the file system with this Explorer app on the activity bar. Which, by the way, is basically all that this is just connecting us to specific files when we click on these buttons in this component that we've made in our theme. So let's check on this thing. Okay, so mine took 3 minutes to run, a little bit longer than usual, but that's okay. All right, so now I'm actually going to go ahead and do everything in the terminal because I think that it's a little bit easier to see what's happening in some of these examples to see what's like the output in the terminal. It's a little bit faster, and sometimes I've noticed that the notebooks can hang a bit when you're doing a bunch of API requests. So total matter of preference. You can definitely try it in the notebook if you want, but I'm going to be doing it in the terminal as well. Okay, so let's start off. I'm going to go ahead and do this pip install. And what we're installing here off the bat is OpenAI, Cohere, and this AI21 package. Now, Hugo, are you familiar with these with these companies / tools?
Yeah, I am, but I'd love for you to explain it for the viewer.
Yeah, so each of them are different model providers. So what we're going to be showing in this notebook is essentially how we can query those different APIs. And it's going to be much like going to ChatGPT and having a chat there. It's like we can create the iterations of that chat loop in our notebook, in our Python code, is what we're going to point out in this first section. And then the reason that we're including many providers is not to make a claim that anyone is the best or so on and so forth. Everyone's got their opinions these days, but just that there's many APIs that you can try and that they all have relatively similar kind of dynamics at this point in time. Do a little bit of comparison as well. Okay, so I'm actually going to just use OpenAI just to keep things simple right now. And I'm going to go ahead and show you the full process for making your API key and kind of how to get going here. So let's just go to Google, type in OpenAI API key. Click sign up. I'll log in with my Gmail. Feel free to stop me too, Hugo, if you have any questions. Now, the key thing is when you get to the OpenAI page, you're going to want to click on your icon over here, and then they have this nice View API Keys section. So let's go ahead and create a new one, Hugo and Eddie Ragathon. It's not just a Ragathon, LLM-a-thon.
Great.
Cool, we'll copy that thing. Of course, I'll delete this after the session. Cool. So set my key.
Yeah, and I'll just add that this is a great example. Eddie will delete that after the session because we don't want you to use Eddie's key. And so Eddie has got this, I mean, assigning this variable, this string in the terminal, but you probably want to use environment variables, right? That's at some point, Eddie.
Yeah, that's definitely a good start. And then if we're talking about serious production use cases, even just passing environment variables around is not very secure. So the additional tools that, I mean, we're going to keep plugging. Metaflow has them built in called secrets is what the name is in Metaflow, but you should definitely be looking for how any kind of workflow orchestration system that you use for production things is allowing you to kind of like pass variables around like that.
Yep.
Super important. Cool. So we've got this generic prompt. How is generative AI affecting the infrastructure machine learning developers need access to?
And can you just make it slightly larger? You can close the contents and maybe reduce the terminal size as well.
Reduce terminal. So you want me to this down?
Yeah.
Okay. How's that look?
That's great. You can actually close the table of contents using the the Metaflow button as well, right?
Yeah.
Great. Thanks, Eddie.
Yep. All right. Now let's go to Chat GPT and type the same thing. Just kind of see what happens. So right now I got my DALL-E 3 thing on. But you can obviously change around the settings. Maybe I should change them to turn it off so we have the vanilla thing. But anyways, we see what's happening, right? It's like kind of this listicle format, has like a little bit of code interspersed, kind of like classic ChatGPT style response here. So that's what we want to get to happen now in our notebook or in our terminal. So I'm gonna go ahead and get started. Let me raise this up a little bit. How's the size in the terminal for you, Hugo? Should I make it bigger?
Yeah, maybe just a little bit. Because it's actually big for me, but because it's going to be on YouTube as well, just making sure that, yeah.
Cool. Okay, so now you'll notice on ChatGPT, we had this model that I can pick up here. How's it going? Oh, they're changing their interface. But we noticed like right here, I have DALL-E 3 selected. So you can select different models, which you can do the same thing in your Python code, which is what's happening here. We're picking a specific model called GPT 3.5 Turbo. And they have a bunch of different ones on the website that you can go look at for different APIs. And it's like a new data science problem in some ways, and also kind of like a dark art, maybe some people would describe it as, of picking which model is good for which use case.
And just on a small note, what you're putting it, this create from ChatGPT is a common way to give it prompts, and you're providing it under messages. You're telling it what role, so you're the user, because you can also tell it things it has said previously, and you can also provide like system level directions and that type of stuff. But having the dictionary role user and then content prompt is kind of just like using the API itself, right? Or using ChatGPT.
Yeah, exactly. We'll actually show you what the same thing, like I'll show you in a sec what the system message idea that you're bringing up.
Great.
We can like see how exactly that compares, and like how maybe a tool like LangChain might interact with the system message concepts in a bit. But yeah, so just like Hugo was saying, this is like the same thing as we typed into the prompt there, or into the ChatGPT UI, and then we get a response, do a little bit of Python unpacking of the API response, and then we can just go ahead and print the string. And similar to what we saw in the ChatGPT UI, we get this kind of like listicle answer explaining how generative AI is changing the infrastructure landscape for ML developers. Pretty reasonable computational power, storage capacity, scalability, a lot of the themes, data pipelines that we're talking about in this workshop. Cool. Now, if you are curious or have a lot of time on your hands, just want to explore, there's other examples here to show you it's very similar to do the same thing with Cohere, where they have just a cohere.generate API. AI21 similarly has a completions API. So there's many options out there for you, and it's definitely a good time to be experimenting with all the different things that you have at your disposal. Cool. So I'm just going to keep skimming through. This is just the output of one of those. And then this section here, make it a bit smaller so we can see the whole table. The idea with this section was basically just wanted to do a quick audit of these different APIs and the endpoints that they have available to them, and then kind of back into a very rough decision tree that you might want to use to start to navigate, like, oh, this is my use case. This is what API I should start to look towards first, or just a little prioritization exercise I did for myself and wanted to share. But note, of course, that these checks and X's and maybe even what the rows in this table are very subject to change right now. APIs are changing really fast. But essentially, like you can look through this in your own time. But the upshot was like, these are some of my opinions after doing an analysis on what these different tools have documented and what APIs they have available. If you want the best chat model, pretty strong consensus view in the AI community that GPT-4 has the best API if you just care about raw quality, and that's kind of your single focus. If you're into multimodal stuff, OpenAI is also going very hard on the images aspect. You might have noticed over here, I was using DALL-E 3 is now built into ChatGPT. I think that may only be on the paid plan. Do you know that, Hugo? Is this the general available, or is this paid right now?
It's only on GPT plus, but that may change at some point. It's actually, it's unclear how and when they're unrolling it to everyone.
Yeah. But yeah, they also, in addition to the image stuff, they also have audio. They have an API for Whisper, which is a very good transcription service that you want to transcribe your podcasts, your YouTube videos, maybe even
also, if people, I mean, this isn't really about developer stuff. It could be. People haven't played around with it. I've got the ChatGPT app, and I subscribe to GPT Plus, right? So, and it has the audio and the image generation in the app. So I literally go for long walks and chat with ChatGPT. And then I'll ask it to generate images and have a look at what it does while I'm strolling. It's actually pretty incredible.
Yeah, totally. It is really awesome what they're doing with voice stuff. It's kind of like a super powered Alexa or something in this way, where the Alexa model is just like full on ChatGPT brain behind the scenes.
Yeah. Minor side note as well. I don't need to, like, when I lived in the US for 7 years, right, Eddie, and spend quite a bit of time there. Like a lot of the time when calling whoever, like my health insurance provider, going down a decision tree, I have to like put on an American accent for it to understand me. ChatGPT doesn't. It seems to understand everything I say. And I don't even understand everything I say. So there you go.
I miss like 30% of what you say, Elite.
Totally. Minimum. All right, let's keep going.
Yeah, let's keep rolling. Okay, some of the other interesting bits here. If you care a lot about content moderation, there's 2 of these tools have dedicated APIs. Not saying the other ones can't do it, just that there is a dedicated API for Cohere and OpenAI for this. Multilingual models, again, like in the next notebook, we'll see that ChatGPT can do this, even though they don't have a dedicated API, but Cohere does. So they're very much focusing on the multilinguistic use cases, I guess. And then finally, one of the interesting ones is I've been looking at AI21, this Israeli company who's making several models. Probably the most common is called Jurassic 2, is like the recent trendy one. They have these interesting APIs for grammar. So if you're into these apps like Grammar, or they have this plugin with a tool I've been using a lot recently called WordTune. They have like dedicated APIs that can kind of give you something like, maybe you can put this in your JavaScript app where it's kind of like assessing, oh, that's repetitive way that your user is writing into your app, or this is a grammar issue, or that's a spelling error. So kind of like building in, I don't know, some Clippy like experience into your app powered by LLMs. Cool. So Hugo, do you want to pop back to the slides to motivate why you might want to use an open source model in the face of all these wonderful tools, or should we just kind of stay in the notebook, do that quick, and then keep rolling?
Maybe if you could share the slides instead of us running back and forth.
So where were we here?
Slide number 27 is what we got up to.
Yeah. So we just went through hitting the APIs, Open API and friends, right? And we're kind of in this generic LLM use case, right? Where we have a generic model, so it's trained on much of the internet. There's a bunch of other fancy engineering happening behind the scenes, and like, sure, OpenAI is doing a ton of other stuff additionally. And then of course, like the thing that we really care about is getting relevant responses to our requests, to our interactions with ChatGPT. Now, Hugo, I'm curious to ask you actually, do you have any like thoughts around like what do we mean by relevance, or like what sticks out in your mind and when you see this picture?
What sticks out for me is that with general information, generic LLMs are pretty good. But if it's something that for me requires domain expertise or something like that, it may not be able to provide me answers that are as relevant for what I actually want to know. Does that resonate?
Yeah, that definitely is kind of how I'm increasingly seeing things. But yeah, I don't know. There's a lot of different definitions of relevance in data science that I think are really useful to be thinking of. And if you want to approach these things scientifically, it's a good kind of like proxy metric to be reasoning about, like what is relevant actually if you had to put it into an evaluation suite.
Yep.
Anyway, so we're in this realm right now of like, we have, obviously it's really high relevance what I'm typing in as a user into ChatGPT. It's like the most relevant thing of any of this is like, what is my question, or like, what is my goal? And the end game is here, we want to increase the response relevance. So like, we're kind of like basically stating here, like, you might get something super relevant in ChatGPT, but it also might just like totally make something up, or be like, hey, I wasn't trained on data since 2021, so blah, 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 I can't help you. Not very relevant. Now, we're still going to stay in this lane when we start talking about open source models. So I'm not like saying we're going to shift into some like new realm of relevance, but like there's also this like whole orthogonal set of concerns around like maybe you can't use an API for various reasons. Or maybe it's like you really do live in a regulated industry where you actually can't have this world where a model that's really crucial to how the experience that your end user has or how data is generated in your products, you can't have that changing behind the scenes without you controlling it or even knowing how it's being changed. You might have legal concerns about like what's going into training data sets of these commercial APIs. That's like certainly a hot topic of regulation right now. And then there's also this like kind of interesting, like the bottom row here, potentially more cost efficient. It's kind of subject to debate, and it's also like very dependent on your own engineering skill and kind of the workflows that you have access to, the hardware you have access to, things like this. But there's a lot of interesting studies going on, a lot of people actually demonstrating you can serve these models yourself potentially, and it'd be much cheaper in the long run. Now we'll see like how the business dynamics go, but there's a ton of different motivations that are kind of percolating for why people might want to use a less good model than GPT-4, even though it's like pretty clearly in most people's view, like that's the most skillful model at this point in time. But there's a lot of reasons. So that's kind of like my brain dump and how I parse this slide. But I'm curious, Hugo, do you have any other thoughts or any things that you'd add around like why open source anyways? Like why not just, are we all going to use ChatGPT forever?
Yeah, I mean, there are lots of different. I think the security concerns are super important. I do think thinking about the governance boundary and where you want fine tuning to happen and what you want to have access to and what you want an external vendor to have access to will be super important. I think latency and cost, right? If you're sorry. Oh, sorry. It's springtime here in Sydney, so the pollen's getting to me. Those plane trees, but what do I want to say? Yeah, latency and the ability to retrieve really quick results may be super important for your application. So that will be a concern. On top of it, you mentioned earlier, Eddie, that vendor APIs maybe are cheaper than fine-tuning your own. I think although that is true, if you spend enough time querying vendor APIs, the costs add up. Whereas perhaps if you fine-tune once, that's a one-off cost and maybe pretty expensive, but then you have your model there. But also, if you want to think, I mean, I don't want to go too deep into this, but if you want to be fine-tuning or training or doing RAG, retrieval augmented generation on your own corpus, perhaps you're even, uploading PDFs or docs to your model. And maybe you don't want to be doing that with a vendor API as well. Maybe you want to keep that all internal. So there are a lot of different concerns here. I mean, depending on what happens with the regulatory space, which the past couple of days we've seen some pretty wild action in, I see the open source space getting more and more exciting, to be honest.
Yeah. I definitely believe that that's a good direction for society to have on offer, and I hope that we keep making a ton of progress. And then, I mean, just looking at the last year, it's undeniable that there's a ton of extremely skilled, talented engineers and scientists working on open source LLMs. So seems like a reasonable bet to like do both in parallel, maybe, even if right now you think the commercial APIs are the way to go.
Yeah, so some incredible scientists, some incredible engineers, and then, in all honesty, with the backing of some pretty like heavy hitting organizations. You think about like Meta is pretty bullish for whatever reasons it has on open source foundation models, and that, you know, that's nothing to.
Governments too, even, right? It's not even just corporations. It's like the Falcon models that have been making so much waves are directly funded by Saudi Arabia government.
Absolutely.
Yeah, it's really amazing the level of investment, to your point, going into all of this.
Yeah. All right, let's jump in, man.
Yeah. Okay. So now there's like obviously a little bit of reasons why maybe not open source. We can go into that another time. And we did talk about like, you know, there's this OpEx CapEx trade-off that we're kind of making here. Unclear if that's even a trade-off. Maybe it's just strictly worse. Who knows? A study for another time. We want to get into the code again.
And the considerations may be different for different organizations as well, right? So
very true. Very true. Okay, cool. So what we're going to do now is basically come back to this generation API that we just saw with ChatGPT. We saw Cohere, we saw AI21. They all have a similar kind of chat completion API. What does that look like in Hugging Face, this open source distribution channel that we've been talking about? So first things first, we need to learn how to load a model from Hugging Face. So to do this, we'll pick the T5 model. T5 is this like kind of generic fine-tuning model that came out of Google in 2022. Really, really good for a lot of different tasks, much smaller than the GPT models as well. So it can be really good for tasks like paraphrasing, things like this, that maybe you don't need a full-on chatbot. What we're showing here is that the way that you load Hugging Face models is dead simple. It's like easier than scikit-learn even, which is wild, like from a data science point of view, that the complexity of what's happening under the hood here has been abstracted away to dot from pre-trained and then just pass a name. And that's coming from somewhere in the ether, basically, which we'll show you specifically what the ether is in a second and how to go shopping there. But what I want to show you here is that once we've loaded the model, this isn't an API anymore. We're not like sending the data across the network to OpenAI's servers. The model itself is on the server that's powering my sandbox. And we can see this when I just print the model state here. Like this is the actual structure of the PyTorch model that's underneath the Hugging Face trainer object. So we see things like all these layers of like self-attention and T5 attention and these specific linear layers inside of the neural network. Like you might, for people who know about QLoRa, that thing I mentioned earlier, like you might notice the Q and the V matrices are important. The thrust of this is that we actually have the model. It's on the device. It's something that we totally own. We like have the state of the model on our side, and we can do predictions like ChatGPT with this. Now, like taking a bit of a step back from that and like thinking about what is Hugging Face again. So there's like this super high level APIs is one piece of it to a bunch of different powerful models. And one of the main APIs that I think it's useful to reason about, whether you're a programmer, whether you're a business person, a product designer, an app designer, however you consider yourself, if you want to get into the Gen AI game, I think one really interesting thing to understand is this tasks page on Hugging Face. Like, look at all this stuff. Like, Hugo, do you have any suggestions about which one to click on, or like any thoughts that pop into your mind when you see all these options?
Firstly, it's wild and overwhelming, but also what a fantastic playground. So I'd encourage people to click on things that interest them. I mean, yeah, I mean, image to image, like that seems incredible, right?
Right. And then like there's more than 200 models that you can pull into your notebook in the same way that I just grabbed that T5 model with one line of code, is what this means when you go to this model hub. And now you just see this one from Stable Diffusion, that's image to image, has been downloaded 8 million times.
Wild.
So there's like tons and tons of resources like this is the point here. Now there's like many tasks like we talked about, like you can do text classification with 3 S's and classification.
That's the
Or
real classification.
yeah, exactly. um, or you can do text generation. And this is what's going to be looking much similar to what we saw above with these chat completion APIs from the commercial vendors. So let's go ahead and get a model name. We're going to pick Bloom 560. So that means 560 million parameters. Relatively tiny in this generative AI LLM craze world. Like 2 years ago, 560 million is a huge model. But now, like the biggest version of Bloom that Hugging Face trained in their big science projects is 180 billion. So almost 1,000, well, 500 times bigger or something like this. Now, what we have done here is we're instantiating this thing called the pipeline. And all you need to pass to the pipeline at instantiation is the model name. So we're picking the Bloom and then a task. So here we're using text generation, but this task could be any of those tasks on the page that Hugo and I were just chatting about. Okay, now our new prompt is we're gonna just type something, and then the way that Bloom is working is it's just gonna do a continuation. So it's like a bit more of a raw version of what ChatGPT is doing under the hood, but it's a good representation too of the actual math problem, which is this autoregressive next token prediction that probably many people listening to this are familiar with. So our prompt is the Generative AI World Summit is and we'll see what Bloom says / hallucinates. Remember, this is a much smaller model, like at least 1,000 times smaller parameter wise than GPT-4. And it's also like there's many engineering systems that are working around OpenAI's GPT-4 to keep in mind that really do set the response of that apart, that API and the ChatGPT interface apart from what we're doing here. So let's just make this a little bit bigger so people can read. But now we have a response. So that was relatively fast, like what, maybe 5-10 seconds. I wasn't really paying attention, but not terribly long. And we have a continuation that's kind of like how ChatGPT makes a continuation. It's a global conference that brings together the best in AI, ML, into artificial intelligence. So we like already kind of see like, sure, the language generation is good, and this is like proper English, but it doesn't have the kind of like emergent intelligence that we see baked into a lot of the answers of ChatGPT, where it's like making a list and it doesn't even realize that AI is artificial intelligence in the items in this list, stuff like this. But it's like a pretty like powerful thing to be able to so quickly load a system like this or a model like this into a notebook and just get going and start building the real engineering systems around it to make something like a ChatGPT. There's some more stuff in this notebook that people can play around with, but it's not terribly different than what we've gone through so far. And I think we should keep moving, Hugo. How does that sound?
That sounds great. And I personally, like, I use Hugging Face all the time, but I appreciate your like whirlwind introduction to it and showing how we can get started with it immediately in a notebook as well. So, and if anyone, plays around with it and finds cool things, ping us in as comments to this video, or on our Slack as well, which I'll include a link to. We have a community Slack with thousands of data scientists and machine learning engineers and infrastructure engineers talking about this type of stuff. So I'll include a link in the video description there as well.
Cool. Yeah, feel free to interject if you have any like Hugging Face tangents you want to go on or anything. We can definitely keep it flexible here. Okay, let's just pop back into the slides briefly. All right, the next notebook we're going to dive into is about prompt engineering. So this is a very overloaded term. It means a lot of things to a lot of people over the last couple of years, not even years, probably a year to be accurate. But basically want to show a little bit about like what is prompt engineering and like how does it help us? So like going back to this picture, it's like we're not really changing the model. We still have this kind of like generic low relevance entire internet training model. And the hypothesis of prompt engineering is that we can go from this kind of high variance of relevance to a more kind of medium relevance on the like t-shirt sizing scale of goodness. The way that we're going to do that is just by making increasingly relevant prompts. So the kind of the first way that we're going to start doing this is just by like structuring our prompts in new ways and using this thing that Hugo mentioned earlier called system messaging to talk to the open API system. Cool. So let's just go back here, go into the prompt engineering lesson, and then I'll hide this guy again. Cool. So in this notebook, it's kind of explaining a little bit the reason for system messages up front. And then we're like actually giving an example of how you can do this in the ChatGPT interface. So what I'm going to do is take this little system message that I've created, which I'll read it to you in a second. And I'm going to go over to ChatGPT and open up the custom instructions, delete all this stuff that I have in here currently. And then under how would you like ChatGPT to respond, I'm going to go ahead and paste this message, which is like a kind of like an intentionally silly thing just to like point out what ChatGPT can do here. And like what the system message is doing to control it. So we're instructing it to write responses like a garden gnome with whimsical and highly informative poems about computer science and business, like so write in a fun way about boring stuff, basically. Make rhymes, be fun and lighthearted, but precise and accurate. Cool. So we've saved the system message. Now we can start a new chat. Let's actually just like match with the notebook. Let's go back to GPT 3.5 here. Now for a computer science topic, do you have any suggestions, Hugo? Or should I just go off the cuff? What's on
Yeah,
these days?
we've just I don't know. We've just been talking about OSS versus vendor APIs. Why don't we ask it about that? I don't know.
Yeah. Describe the motivations for choosing open source or vendor APIs when building machine learning systems. How's that?
Yeah, great.
Let's see what it does. Okay, so now we see our garden gnome worker going to town with its poem. In the world of code and data so vast, two choices before you to ponder and contrast: open source APIs like a forest so free, or vendor APIs like a cultivated tree. So it's definitely tapping into the Mother Earth part of the system message.
Yeah.
It's got the rhyming, but okay, point is like you can get it to like behave in certain ways. So maybe if you don't like it, that like you don't want to pass on this thing that ChatGPT does to your users, where it's like, I wasn't trained on data since 2021. It's this like pre-canned way that it responds. Like sure, it makes sense for OpenAI to do that at their scale, but maybe that doesn't make sense for your use case. You can use system messages to kind of like get it to like say that thing in a different, more randomized or more general, like human way.
Yeah, and this is a whimsical example, but let's say like the person you're generating content for was English was their second language, for example. You could say, please use vocabulary and grammar and complexity which is appropriate for people with English as a second language. Or you can describe the level of professionality. You like use language that is appropriate to speak at a shareholder meeting.
Totally. There's so many. Yeah, that's a great example. Or like maybe even something more technical is like you can say like only respond in JSON output. Is like these models are actually quite good at this kind of thing these days.
Yeah.
And you a lot of times just get away with not even doing fine tuning or anything and just like shoving that into a system message, and it does a reasonable job.
Yeah. Although you need to be careful with stuff like shareholder meetings. Eddie, I think knows this. I've started watching Succession recently, so you definitely don't want the language used in the Succession board meetings, for example.
Oh yeah, what season are you in?
First season. So.
Oh man. Oh okay. Yeah. Well, it's not even worth talking about at this point.
Yeah.
And also we're recording a video. So okay, sometime
we'll be continued.
Yeah. Succession meets AI at some point in the future. Okay, cool. Now I'm actually going to go ahead and select my kernel again so I can do my installs in the notebook here without killing my terminal. What we're going to do now is use LangChain, a trendy tool that's got a bunch of different features built into it for like kind of connecting these LLM systems into existing software systems. So what we want to do is basically the same thing that we just saw. So we're going to have a system message. Just clear a little space here. We're going to have a system message and then the human message. Now, the human message is going to be, this is the thing that I am typing into ChatGPT. So this is like us asking it the question about open source versus vendor APIs or something. And then we also have the system message, which this is the thing like you're a garden gnome or only write in JSON or only write like you're Logan Roy or something like this. And in this case, what we wanted to do is we're going to just like use ChatGPT to translate language. So we're going to say you are a helpful assistant that translates A to B with many years of experience teaching beginner language students. And then let's see what happens. So we'll go ahead and import some stuff from LangChain. LangChain has excellent documentation, in my opinion, if you want to like read more about this stuff. But what we're importing here is just like a little template that helps us wrap the prompts, and then something that helps us wrap the OpenAI API requests. So it's kind of like LangChain 101, maybe you could describe it as. Have you used LangChain much, Hugo?
Yeah, I have. So I'm wondering if maybe you could motivate a bit more why we even want to use LangChain here.
Yeah. I'm also curious to hear your thoughts on that. But basically here, I think LangChain is like becoming increasingly common, and like many people are curious about it, and like how does it actually help me compared to, say, like why not just format these as Python strings or something like this? Like why do this like extra level of templating kind of where it looks more like a Jinja almost or something like that? My personal answer is I think like as you get more complex and you start chaining these things together, like as the name suggests, that becomes harder and harder to manage and harder to trace in between like the hops of all the different ways that your prompts are changing, and those kind of like this like Russian nesting dolls situation happening of like prompts within prompts. So I think that's one thing, is like to have a nice framework for organizing these is like the first thing I started using. But now increasingly they have a whole bunch of other stuff that's like very interesting in terms of interacting with LLMs that I'm curious about. But it's kind of beyond the scope of this. Like the short answer for this session is that I think these APIs are just very clean and a little bit easier, a little bit less boilerplate than working with the APIs directly.
Yeah, I agree. I think it's a good way to manage complicatedness and or complexity. I think it does introduce certain amounts of complication itself, and that may be necessary, but still early days. But it does help us in these cases for sure.
Totally. Cool. Now, once we have our little API, what we can do is we can call chat, and then we're going to format our messages. So I've just wrapped a little function around here. So we're basically making our own little Google translator in 3 lines of Python code. So I'm going to go ahead and just define this function in my terminal. All right, cool. So we've got a little translate function. Now, let's go ahead and we'll type from English to any suggestion on language, Hugo? I can't put Australian. That's not even sensical.
I mean,
maybe should we try French?
Yeah, I'm just wondering if it'd do something like Mandarin or something like that, which has a totally different alphabet and way of structuring words.
Yeah, I definitely got ChatGPT to write in Japanese. I can't read anything in Mandarin, so it's a bit hard to say now. But
why don't you do Japanese then, if you can read Japanese?
Yeah, I can read a little bit of Japanese. Okay, so let's I'll just keep the same message to keep it interesting, to keep it straightforward. Yeah, so we see, okay, so we said I love programming, and we want to go from English to Japanese, and we see watashi wa programming ga daisuki desu. So it's like, as far as I know, that's how you say that in Japanese, pretty direct. Now, what's kind of cool is we can also do stuff like this now. So you can say translate from Japanese to Spanish. And this is kind of this is the reason why it's like important, I think, to pay attention to that templating stuff, which LangChain just kind of like forces you to do. Not that you couldn't do it in like raw Python strings or something. But it's like LangChain like kind of gives you like a little head start. Like it gives you like a bit of an API for thinking about this, reasoning about this. So now it kind of translated accurately. I love the programming, maybe a bit different. It's not like the gerund form in Spanish. But let's now finally complete the loop and see if we can go back to English and if it says something reasonable. Oh, I need to get rid of that quote. I'll get off this example after this, so bear with me. I love programming. So it went perfectly back. Full circle now. We've got like a Google Translator clone that's like working reasonably well in 3 lines of Python code. Cool.
Amazing.
Now, end of this notebook, there's a bunch of research papers here that have been linked. Essentially, there's a lot of different research dimensions branching off of this like basic prompt engineering idea. Like, how do you, like, without changing the model, how do you get these things to behave in a more useful way to help you complete goals or do something? I'll kind of leave it at that, and people can explore these papers and like add their own stuff, and like please suggest in Slack if you have other things that you've read that are interesting that you'd like to see in notebooks like this in the future. But Hugo, I'm curious, if are there any like things that you see in this chart or any kind of like angles on research around like all this chain of thought, prompt engineering stuff of late?
I think there's so much to say here. It's not. I think we should leave it like this in order to move on with other aspects of the tutorial. But people can jump in here. I actually, one thing I'm particularly interested in, but we should say this for another time, is like zero shot prompts and ranking and that type of stuff. But yeah, there's a lot of fun stuff in here. But let's leave it for the time being.
Cool. Let's pop back to the slides very quickly and we'll motivate. How do we go from prompt engineering to now like this RAG, retrieval augmented generation land? Okay, so now we've got some new entities in our chain of events that's leading to this response and its corresponding relevance to the end user. So similar to before, we have a prompt. Obviously, that's high relevant. That's what the user is typing into the machine. Then before, we just had this big blob. We just had this big generic model blob. The prompt was going directly into that thing, and there was no extra like data being mixed in. The new thing that RAG is adding is we have a little database here, and we're going to retrieve something from the database. That's the R in RAG. And then we are going to augment the prompt with that thing that we retrieved. And then we're going to use that thing to generate the response that the end user sees, with the hope of like us injecting some relevant data into the prompt is going to like have a big effect on the relevance of the response.
And maybe one point to make here is, as we'll see later, another way to inject relevance is fine tuning and that type of stuff, but that requires significant compute and time, whereas retrieval augmented generation is a way of doing it without requiring retraining, right, Eddie?
Yeah, that's right. That's right. We're still using models because we're putting vectors in particular into this like database looking thing.
So is that a vector database?
Yeah, it could, well, okay, that term has become like kind of like an industry term, which we can talk about this in a little bit maybe. It's just anywhere that you can store vectors. So I guess in the like very literal sense of the term vector database, yes, that is what it is. It's like we take embeddings from an LLM or any kind of language model, and then we put them somewhere. We put them in an index is what the tools typically call it.
Great. Let's do it.
Sweet. So yeah, we're kind of like going into the library, finding stuff, breeze through the slides here. So this slide actually does explain exactly what it is, Hugo. What I was just talking about is like
great.
we have structured data. We're just trying to put it somewhere like that it's indexed, that it's ordered. And then when we have a new example, like we see in the second row, we can make one vector and then we can do some kind of search pattern. Very old, like tried and true data science method here. Like the way that we can search is like very mathematically well understood. Cosine similarity works really good. It's what OpenAI suggests when you use their embedding API, so on and so forth. That's what we're going to be doing here. Any questions before we dive in?
No, super excited to dive in.
All right. Cool. So as I mentioned, there's a bunch of different vector database providers in the market right now, some open source, some closed source. The one that we're going to be using today is called Pinecone. This is closed source, and we're going to kind of show you like the process of getting your API key and kind of like going through the whole end-to-end chain. So similar to before, I'm going to have to connect here and then run my pip install. And then we're going to need a Pinecone API key. So to do this, let's go to Pinecone. Actually, this is less helpful because I've already been on the console. Let's do like the from scratch way. So if you go to Pinecone, the quick start page, you'll see like big sign up free button. We click on these things. I can continue with my existing account, but that's also the flow you'll use to make a new account. And the end goal of what we're trying to do here is make an API key that we can use. I've already got one, so I'll just copy that one. And then to be complete, let's just delete this index because we're going to recreate it in this example, just to kind of see the full thing. So I'm going to copy my API key. And again, like Hugo was saying before, like not a great practice just to be pasting your API keys and variables and stuff like this, but of course, this is just a demo. And then the other thing that you're going to want to set is you're going to want to take note of the environment in Pinecone here. These are kind of like availability zones, maybe if you're, or regions, excuse me, if you're familiar with AWS terminology. Cool. Okay, so now we've got our setup. We've got our Pinecone client installed. So we should be able to go ahead and initialize. Okay, great. Now, we are going to be using this RAG tools that we created. And this RAG tools is coming from a repository that we put together at Outer Bounds with our collaborator, Federico from Stanford. I'll go ahead and show you this. It's in the RAG demo repository. We're just installing it from this GitHub repository. We did a whole blog post about this. So if you're curious about details, definitely check out this post. And this repository has a bunch of stuff. And that's where we're getting this tool. And basically it just provides a simple wrapper around creating embeddings and then a way to parse specific data. Cool. I'm realizing now too that I forgot something interesting up here that we're going to need. We're going to need both the index name and the metrics. Let's just go ahead and define these variables right now. Okay. Now, what we want to do is basically take a couple chunks of text and put them into a vector index. So super high level concept. Hugo, any questions or anything that you'd want to add before we just go like show the loop of like getting data into Pinecone and then retrieving it?
No, I'm good. I'm really excited to see how this works, actually.
Okay, cool. So we just got a list of Python strings. Hello, Gen AI friends, Metaflow, blah, blah, blah. Lots of people, machine learning, XYZ. Cool. Now, just like before, we went to Hugging Face and we found a model. This time we're using the sentence transformers kind of repository, this like place where you can search for, sentence transformers specifically is like quite good for embedding models is why we're using it here. And this is the name of the model that we're going to use. This object is a little wrapper that's in the RAG tools thing, but it's like a very thin wrapper around like the Hugging Face API for doing this. So let's actually just go ahead and do these two together. We're going to make the encoder, and then we're going to encode these 3 text samples. So we'll get 3 vectors as an output. So now we see Hugging Face doing a lot of action, kind of downloading the model, and then we've already produced our embedding. So if we print this out, we'll see it's just an array, and we can do a shape. We should see 3 rows. And then the other thing that we see is there's 384. So these are like the dimension essentially. So let's actually just set that as a variable, which we'll use as we instantiate the Pinecone index. So now earlier you saw me kind of delete an index in here. So we have no indices. And by the way, the reason I did that, in addition to making the demo more interesting, is that you only get 1 free index on Pinecone. So just know that if you're going to make the free account, you can only do 1 of these things at a time for free. Now to instantiate a new index, which like this is that database, that purple database picture that Hugo and I were talking about on the slides. All you need to do is run 1 line of code, create the index with our index name, specify the dimensionality of each vector. So how many numbers are in the list of these embeddings for each string, and then the metric, which we chose the cosine similarity metric, which is like nothing, it's like not a special thing really. It's you can just read about it if you're not familiar, probably on like Wikipedia or something is the best place. Like very simple kind of dot product formula for like comparing how.
Yeah, scroll down though, because it's way easier to, you don't need the math. It's way easier to see in a figure if they have a figure.
Let's have a picture here. So I'm gonna just go to the
Anyway,
images.
oh yeah, no, yeah, exactly. That's a calculator. That's amazing though.
Yeah,
It's the
right.
angle between things. You have some embedding. When things are close, they point in the same direction. When they're not, they point in opposite directions.
Totally. Cool. So let's see what's going on with our index. How are we doing? Can take a minute to create. So you see we're still initializing. Eventually this thing will turn green, and then that Python code that we're running will be done. Let's see. Oh, I was going to ask a question, but it already turned green. So let's keep moving. All right. So we see that it's existing now. So now we're like freed up in the Python terminal again. Now that we've created the index, we can actually fetch it and use it as a Python object. So all you need to do is pass the index name. And then this operation is where we're actually going to put these embeddings, these vectors, inside of the vector index. So you can see like we're doing this very manually in this case, just for education purposes. But the call that we're making to the index is called upsert. And we're just putting in a list of vectors, each with an ID that we're specifying. So like one interesting thing to think about is like maybe this is an index or some other like key that you could use to connect to another database. Or maybe you're storing a foreign key in this metadata to some SQL database or something like this is interesting to think about from an app design point of view. But let's go ahead and just put all of these embeddings into the index now. You can see that happens super fast. And now in this cell, what we're doing is kind of like, okay, that all happened offline, maybe like that's all running in some workflow in the background, which is what we'll get to in the next lesson. But now we're at like runtime. We're in the app. So like Hugo comes into our new chatbot powered by this RAG system. And Hugo's like, what does Metaflow do? So this is our query. And then remember, we're going to use ChatGPT. So it's like we could also maybe ask a question that's like totally like ChatGPT would have no idea about, but then the data is actually in these examples is like when RAG is working well. But in this case, we're just going to kind of like show the mathematical process first. Now what we do is we use the same exact encoder as before. So we have kind of this parity between what we put into what we upserted into the database and then the way that we're producing the vector now at runtime for the query. So just like before, this vector is just a big list of numbers. So this one will have shape 384, where remember our embedding had shape 3 by 384. And now what we're trying to do is create matches. So like since we only have 3 examples in our database, the top K being 3 isn't very interesting. It'll just return everything. But let's go ahead and return the top 2 of the 3 responses. And we're just going to run index.query is the Pinecone API for this. Very quickly, we get our matches. We'll do it just a bit of unpacking of the response in Python. And then we can go ahead and see that now we get in this response, we have a list of dictionaries. In the first dictionary, we can see a bunch of different information, including the ID of the vector from the database, the score. So this is the cosine similarity as we were looking at in the pictures on Google Images. And then since we included the text in the metadata, we're actually also returning this as well. So that's basically the end-to-end loop. And I'm going to go ahead and delete the index now. But Hugo, do you have any questions or anything?
Yeah, let's just look at the scores and see if it makes sense to what we would think, right? So to be clear, cosine similarity varies between, is it -1 and 1?
Yes.
Because it's a cos of.
Yes. Oops.
0 and 1, sorry. Yeah, of course, because we're taking absolute values. Okay. So great. So 1 means.
Wait, didn't you say? Oh no, you said yeah. It's not. You're right. It's 0 to 1, not -1 to 1. To be clear,
yeah.
Right.
So what are we getting cosine similarity to here?
So we're getting 0.24 for the second entry and 0.61 for the first entry.
And so what are the terms there?
Remember, our query was what does Metaflow do?
Yeah.
We would expect this one to be, I mean, on a relative scale, it's like maybe 3 times more relevant is like what the cosine similarity metric is telling us in like very loose terms. that this first response is maybe 3 times or so more relevant than the second one relatively. Let's look at the second one first, the one that's supposedly worse. Lots of people recognize machine learning systems require robust workflows.
Yep.
This is the input text that was being embedded.
Yep.
And now one that this retrieval mechanism is saying matches better is Metaflow helps you build production machine learning workflows. So in response to this as a query, like I would say that that's pretty reasonable.
Absolutely.
Ranking.
Yep. And I think your heuristic around it being 3 times is pretty good. I don't think it is actually linear though.
It's definitely not linear.
Yeah,
that's a good call out. Is like that's mathematically not a say.
So yeah, but this is good. So what we're seeing as we're doing a vibe check here essentially is that Metaflow helps you build production machine learning workflows is more relevant to what does Metaflow do than lots of people recognize machine learning systems require robust workflows. Okay, so that's nice. It's working.
Yep. Cool. Now
Awesome.
in the rest of this notebook, okay, go ahead.
No, we're good.
Cool. In the rest of this notebook, now what we're going to do is instead of just having 3 hand-coded examples, we're going to extract a bunch of different text chunks from Metaflow's documentation. So that's another thing that we built in this RAG tools thing is just a way to parse the structure of the markdown files that are metaflow.com or metaflow.org and outerbounds.com. So that's what we're importing here. These are like custom tools for parsing. Like they're useful for general GitHub repositories that are written in Markdown, or you can write your own parsers. That's another thing LangChain has, by the way, is they have a bunch of different parsing tools to try out. Yeah, let's just keep rolling here. Then we're going to load these all up as a data frame. So just to be really clear about what we're doing, we're crawling this repository. This is what becomes docs.metaflow.org. So you'll see all the columns on this left-hand side here. These are going to match the different folders inside of the docs in Metaflow's documentation repo. And that's the thing that we're crawling here. And then the result of this crawl is basically we've chunked into a data frame by the headers in the documentation pages. So we kind of have like the H1s, the H2s, these are the different chunks of text. And then the thing that we're going to embed here is this contents column. So if we just look at that, and then maybe just like pluck the first one, we can see that we get this like mix of like what's just directly coming from those markdown files. So we see a little bit of HTML in here. And then just kind of like the string pattern. Cool. So this is going to this is our data set basically. So we'll do a little bit of filtering. It's kind of like normal data munging, just kind of getting rid of the ones that have very few characters, very few words. And then we're going to get into the actual embedding workflow. Basically the same thing that we did above. So I'll just like kind of blitz through this because it's not that different than what happened before. Feel free to pause me, Hugo, if you have any questions or comments on any of this.
For sure, we're good.
And then we'll do the longer part here. So before, like we embedded and it was almost instantaneous. So we didn't even really notice anything was happening. But it's important to remember that like, we're still using a deep learning model here to embed these documents. So we see now like even getting up to like there's maybe 400 rows after the filtering in this data set. It's like already becoming a non-negligible amount of time where we're just kind of sitting here waiting. And you can imagine if you had a data set of like 4 million documents or something instead of 400, this would become like really, really slow to do this all sequentially, like how it's happening right now. So that's just like to kind of like foreshadow like one reason why you might want to think about like how do you break these systems up and parallelize them or something along these lines. Okay, cool, but that's done relatively quickly. In our case, it really doesn't matter. We can do it all locally. Again, we have the same dimension. And let's just check the actual shape of the embeddings. So again, 384 for each vector, and then we have 441 vectors now. And this will be matching the shape of our data frame. Cool. Okay, so same thing as before. We'll just reinitialize Pinecone. We'll pick the Metaflow documentation as our index name. And we will do, should we try a different metric, Hugo? Maybe we can shop for new ones.
Yeah.
Not even really aware. Okay, so the 3 that they have. Oh, so actually you were correct earlier. In fact, Pinecone is normalizing the cosine similarity in between -1 and 1.
Yeah, okay. Yeah,
So it's like
so
a bit
that's
of a
an
factor.
yeah.
By default, I think we were correct in the 0 to 1.
And that's an implementation detail. I just wanted to get kind of a rule of thumb for whether it was working or not. So that's totally cool.
Yeah. So the 3 that they have apparently right now, and like all these different providers have many different flavors of these metrics and things to explore. But is there any of these 3 that you'd want to try out? Maybe the Euclidean or the dot products?
I'm easy, man. I think if the point is to just demonstrate that we can switch out a different metric, either is good.
All right, fair enough. Fair enough. Cool. Now I'm just going to go ahead and skip this conditional block because we know we deleted the index. Go ahead and recreate. So now going back to our, I deleted the app.pinecone. So now we'll go ahead and see this thing is initializing, creating our index in Pinecone. And then we're going to go through the same process of just upserting the documents, searching the index, and now we can start to get into more specific questions about Metaflow. So like while this index is creating, maybe we can do a little bit of a detour and think about like how would ChatGPT respond to this question? Just totally like if we wanted to have ChatGPT in the Metaflow documentation somehow as a chatbot, how would it respond if a user asked this question if we didn't modify it in any way with RAG?
Yep.
So to
Great
see
question.
this, I'll get rid of my like GNOME prompting, and we'll just go back here.
I'd be interested to see how it does it with the GNOME prompt, but no, I'm
Yeah,
just
I mean that would it wouldn't be a fair analysis, but it would probably be more fun, which is like such is the life of a data scientist, trade-offs.
a GNOME data scientist.
Ooh, now you're talking my language.
GNOME
Okay,
language.
so basically like kind of what we would have expected here. Like it didn't even know that I was referring to Metaflow in this question, which like why would it? If like that's not ChatGPT is not indexed to only talk about Metaflow or something. It just gives this like generic BS response that's like kind of useful to like understand how Conda behaves in general. But if a user asked that in the Metaflow documentation, like that would be pretty bad to give as a response. It'd be like borderline useless.
It's also useful to know that you got to write YAML, dude.
Yeah, right. That's a whole nother level of pain. Okay, now where was I in this notebook? Yeah, okay, so we've created the index now. Yes, so one thing that we're going to do now is we're going to use that data frame. So this guy, we're going to use the indexes from this data frame as a way to pass metadata into the Pinecone index. So like what this is really setting up is that not only is Pinecone going to return the relevant context, it's going to return the index so that we can get like a small data frame of those retrieved results. And one thing that you'll notice in the columns of this data frame is that we also have this thing page URL. So if we look at the page URLs, one of the reasons that we would want to do this is now we have a specific link to each chunk of text because these are all indexed by the headers in the markdown, remember? So like this is a naive way to do this. There's definitely more sophisticated ways. And maybe another reason to look at tools like LangChain is they have this stuff built in. But what you'll see is like this, you can now like return the relevant results, give that to ChatGPT, but then you can also give it like actually like cite your sources and like point people to this as the thing that you kind of conditioned your generated response on. Okay, so I'm just going to keep moving and stop chattering because this is already a very long video. Okay, so just creating the vectors, and now we're going to upsert them into our database. Super fast again. And now we're going to take the same query that we typed into the ChatGPT. We're going to use our template from LangChain, just like we saw before when we did the like little Google Translate clone. Now we have our chat prompt, like chat. And we'll get a response. And again, like we're not doing anything special here. So we should see something like what ChatGPT said before. Like we're not retrieving anything from the database, not doing anything interesting yet. So yeah, basically we see a bunch of stuff about the YAML files, Hugo's worst nemesis. We see a little bit about prefects. Like again, if you got that in the Metaflow documentation, be a little bit confusing, but maybe a little bit better even um, than the
Yeah, it's
ChatGPT.
prefect and Dask, actually. Interesting.
Yeah, interesting combination. Yeah. Cool. Now, how do we actually use the stuff that's in that data frame?
Yeah.
Like, how do we actually make this better? So let's set k equals to 5. So this is like the number of things that we want to retrieve from Pinecone every time we do this query matching. And then this is the exact same
And
code.
why 5? Like, what's a rule of thumb for choosing K?
Great question. This is like application design in my point of view. Like there's some data science to it, but it's also like one way I think about this is like there's this tool that I really like called Perplexity AI. Are you familiar with that?
Can't recall. Oh yeah, I am.
Yeah, that it's not like super different interface, but if we ask it like how do I use Conda with Metaflow or something, it one thing that I like that Perplexity does is like Bing also is doing this, and like ChatGPT increasingly has this functionality too, but they're very much like indexing on like they're doing a search process that's like somewhat like Google to index the internet and then give you actual like cite your sources kind of vibe here. So like that's why I'm picking a number that I think would be reasonable for like how many sources do we want to do this on?
Okay.
Is basically how I'm thinking about it in this context, but
Great.
it's very app dependent is really my answer. Do you have any thoughts as I type this out and kind of let it run? Like, what do you think would be a good heuristic or rule of thumb?
I think, as you say, it depends on the use case, but I think in all honesty, unless it's a really complex thing, 10's too much to start with. 1's probably not enough. So then picking something between 1 and 10.
Yeah, yeah.
And 5 is between 1 and 10, and it's in the middle there.
That's true. That's true. All right, so I'm just doing a little post-processing now, getting the indexes into the data frame. So we see that we've now got 5 indices. So these are the most similar things returned from Pinecone. And let's actually turn that into a little data frame. So now we have that thing that I was talking about, basically. We have 5 chunks of text. We can shove this into the prompt that we give to ChatGPT, and then we can also tell it, here's the URL, like use this as a way to like refer people to a real source that's not you generating tokens, essentially. Sweet. So now let's just to complete this loop, I'll do this part super quick because I think people that are still following along probably get this by now.
Just as a little teaser, we're about to get to, actually building live production systems with all of this stuff. So
exactly. So stay tuned, but like just wanted to like complete this train of thought because like we're not quite done with what you do with this context now. Like a really important, this is actually maybe the most important thing to think about as an app designer is like, how do you now use the 5 results or the K results that you've retrieved in the prompt? This is like a mixture of like data science research, app design. How does your like product actually interact with your customer's experience? Many different moving parts here. We're still using that kind of like LangChain-ish pattern. Well, no, we're actually using LangChain still. So I shouldn't say LangChain-ish. And now what I'm doing is like this loop in particular is how I've decided to design this app to construct the context, where I'm just looping through the rows of the data frame. And then I'm going to be having this like, here's the context, and then here's its URL. And then I'm just going to be telling the model, like, do what you will with that, essentially, based on what's in that system message that I typed in above. And I get the template for the user query. Now we'll reinstantiate our chat prompts. Just like before, we have the system message, we have the human message. Get the chat object, and then we will do the loop. So now this is actually calling OpenAI behind the scenes. This is kind of the LangChain-ism of it all. Same thing that we did before. And then we can print our response. And now hopefully this thing is actually relevant to a Metaflow user who types that thing about Metaflow that ChatGPT had no reason to know is about Metaflow until we did RAG. To specify Conda dependencies in your flow, you can use the @Conda decorator. The decorator allows you to make specific Conda packages available to individual steps in your flow. Here's an example of how to use the Conda decorator, blah, blah, blah. So it's actually writing Metaflow code now. It knows that we're talking about Metaflow. It's correctly identifying that this is the way that you say like things from Metaflow. Like this specific piece of text is almost surely actually from the documentation itself. So yeah, that's basically like closing the loop on this kind of like initial foray into RAG. Any thoughts, Hugo, before we keep rolling?
No, this is great, and an exercise for the reader or the listener or the learner or the viewer, the watcher, is we've recently released our at PyPI decorator, so you can play around with it and see if you can answer the question how to do all of this stuff with pip. And this is one of my favorite parts of the Metaflow story. Very much talks back to our production deployment and making sure all your cloud workstations are equipped with the same software as your local workstations, that you can use merely a decorator. You don't have to write any YAML or anything like that to specify what packages you want for each step in your workflow, or you can do it at an entire workflow level as well. Don't want to go into that too deeply. But that's one of the many things that I love about Metaflow. I mean, I wouldn't say it quote unquote 100% solves the dependency management story, because if it did, well, you know, that's flying to the moon, really. But it very much in my daily work with dependency management.
Totally. And that's very much in the direction of now the next run of slides we have here, which is about moving this system that I just kind of unrolled in a terminal in a Jupyter notebook or whatever. Now, like, how do we actually put this into a production system, right? It's like we need to think about exactly to Hugo's point. Like, imagine now, like, I made this RAG pipeline and I pushed the whole thing into production, and now a new feature lands in Metaflow's documentation, like the at PyPI decorator. How do I know, like, when is the data that is the documentation of that thing? Like, when is it actually going to be in this RAG pipeline? Becomes a super important question in practice then, when it's like we're trying to solve around this issue of like ChatGPT doesn't know the context that we're talking about Metaflow. It doesn't know the context past whatever cutoff OpenAI's training data is. Like, how do we actually like build systems to continuously be refreshing something like the Pinecone index or the LanceDB index or whatever tool you use to?
Absolutely. And I think you've motivated it well here, Eddie, in terms of, you know, you quote unquote wanting your flow to know when this stuff has been done. But I even think in some organizations, different teams may be responsible, and a lot of the time will be responsible for different parts of what's going on here, right? So your data pre-processing flow may be owned by a data engineering team, and the model flow by a data science or machine learning team. So, and you don't, you know, want to be messaging people on Slack every time the pre-pressing, you know, Slack is where work happens, but APIs are where work happens as well, right? And event triggering and event buses are where work really, some of the exciting work happens. So perhaps what we're moving towards is figuring out how a data pre-processing flow can actually just trigger a model flow, which then could trigger an inference flow, right?
Exactly. And maybe as you're doing your data pre-processing around like curating your RAG pipeline, maybe something goes wrong, and then you want to use a Slack API to alert Hugo, like, hey man, something broke. What do we do about this? And then we like have a little debugging session to get together or something like this. Like it's important to start thinking about like, let's get out of the Jupyter notebook mindset for 1 second and kind of zoom out and think about, if we want to run this stuff in these workflows, what sort of hooks do we need in that system, and how do we afford them? So I guess that really the argument of this section here is Metaflow is a nice tool for that.
Yep.
We're going to show you how to do it with the same code that we just did in our Jupyter notebook. So Metaflow has a lot of these features we've been discussing, but it also has this notion of being like an orchestrator that you can either schedule jobs and run them on a calendar, or you can trigger them based on events happening, or like in the story Hugo was describing, based on other workflows, maybe from a different team. Finishes data pre-processing workflow that runs every night at 12 p.m. or something, or that would be every afternoon at 12 p.m. And then whenever that workflow finishes, we train a new model, or we do something, do whatever downstream.
Yeah. And these are all really nice examples, Eddie. And I do, as we're kind of moving towards, I just do want to clear, like, the abstraction layer we want to think about these things are events, right? When something relevant happens, that's an event, right? Exactly. Such as data being updated, S3, something in an S3 bucket changing, a workflow finishing, whatever it is. And whatever you think is an important event.
Exactly. Now, connecting this event triggered world to RAG, or maybe scheduled workflow world to RAG. One of the ways that we wrote about this in the blog post I mentioned earlier is like, how can you visualize this entire system of happening? Like basically, we've already went through kind of the dark gray box on top here in the last notebook. So it's basically this idea of like, we have this online user who sends in a query, like the thing about the vague question about Metaflow. That thing needs to get embedded in the same way that all the other things in the vector store got embedded. Then we do this matching process, get something that we consider kind of like factual data out of that matching process, and then use it to make the LLM generate things that are much more tightly scoped to our actual documentation or whatever source we consider a source of truth. Now, like, how do we actually populate that index is really the question that we're asking when we get into the workflow realm and what we're going to show you how to do in the Metaflow sandbox. Which this is basically taking the code that we just wrote to like chunk up the Metaflow documentation and then embed it into Pinecone. And then we're going to run that every night. And we're basically going to chain the different parts of the workflow into 3 separate workflows that are all like triggering each other essentially as an end-to-end chain.
Super cool, man.
Specifically, we have 3 sections. We're going to have this markdown chunker, which is named, I just like the word chunker.
Yeah.
This thing is going to run on a schedule, maybe every night. You could change it to hourly, run it as a cron job, whatever. When this thing finishes, we're going to do the pre-processing and kind of log a card is the Metaflow terminology, which shows a data visualization of what happened. And then when that thing finishes, it's going to trigger the Pinecone indexing part. So like one reason why you might want to think about separating stuff like this into like either different steps in your workflow or like we see here into just 3 independent workflows is that the first 2 are like relatively low resource intensive. Maybe they're just things that we want to like can do like massively in parallel on very cheap computers. But this third one where we're actually going to compute embeddings and then put it into the Pinecone vector indexer, that could be very compute intensive. Like if we had 4 million documents, the story we were talking about earlier, maybe we need 10 machines with GPUs on them or something in parallel. And we want to like quickly be able to turn that on. So it's like useful to kind of separate that part of the workflow into its own little like subsystem.
Sorry, maybe
Yeah.
it's just worth adding. I mean, Eddie has just really talked about the 3 different steps that we want to trigger one another and why we've chosen why those 3 steps with very reasonable choices there. These are design choices that you want to make yourself. So you might have a whole series of steps involved, and maybe we'd choose to do it in a different way to you. But depending on your organizational concerns, how your teams work, business concerns, compute concerns, you might, parse this, chunk this differently. So
It's all about chunking. No,
yeah,
that's a great point. Yeah, it's really like up to you as a system designer is the idea. Like Metaflow is not telling you what to do, it's just giving you primitives to build whatever system you need to build.
exactly.
So like what are these things actually though? Like I spoke a lot at a high level on the last slide. Like what I mean by you can schedule the markdown chunker workflow. This is a simple decorator in Metaflow when I say that I want to run it every week. When I say that these are like relatively low resource, I'm just saying like these are 8,000 megabyte machines. That's all I really care about. I want you to run it from this Docker image where I've already like packaged up all my dependencies. So before Hugo was kind of talking about Conda and the pip decorator from Metaflow, you can also use Docker is kind of what this is showing here. So Metaflow is like very complete coverage of the different dependency management solutions.
And Eddie, just to stop you for 1 second, I've been so excited about all the LLM stuff we've been doing. I actually forget if we've really introduced the basics of writing a Metaflow flow.
Yeah.
Maybe I'll just say a few words that it's you use a class definition. It's object-oriented programming. We have templates for this type of stuff. If you're not so comfortable with that, you use @step to define each step. We don't really mind we want you to do whatever steps you want, essentially. We do enforce, Metaflow does enforce a start step and an end step, but you can do anything in between, including like big branch outs and massive parallelization, as long as you join correctly, of course. So you're building a DAG here. It's all Pythonic. Instead of writing YAMLs and this type of stuff, we want you to be able to use decorators such as @Kubernetes. And we can see where specifying the containerization story here, the Docker, you can use @PyPI, you can use @Conda as well, specifying the amount of resources, whole variety of decorators which allow you to specify different things. As part of the productionization story, you can see all you really need to use here is an schedule weekly equals true decorator here as well. And I presume what we're going to see is how you deploy that using Argo or something along those lines on the command line, which is a relatively simple command. The reason I wanted to make this clear is that Metaflow wants you to write your Python code the way you like to write it. And all Metaflow enforces is some basic design principles around how to write a DAG, directed acyclic graph, or machine learning workflow there. We've got in our onboarding tutorials on the sandbox, you can check all of that stuff as well. That was just kind of a whirlwind 2-minute introduction to what's happening here for those interested.
Yeah, perfect. Yeah, just to like piggyback on one thing Hugo was saying that I think is very important here is like we just see the outline of a Metaflow workflow here.
Yeah.
All the user code, like your research code and your business logic, is these ... inside of the start step and the end step. This is where you put, maybe you call a script that you've written and would run independent of Metaflow otherwise. Or maybe you just put the code directly here because you can run arbitrary Python code. Point is that the code that's inside this start step getting lifted up to run in Kubernetes with 8,000 GB RAM inside the Kubernetes pod, these kinds of things.
So cool.
Cool. So the second flow, just another example of what this stuff looks like. So we can connect to our Markdown chunker workflow, that one that we're going to deploy in a second, that we just were looking at the actual Python code of. We can connect this workflow to now run whenever that one finishes using this @trigger_on_finish decorator. And then we see like maybe another Metaflow use case here that we have this notion of parameters. So you can like pass different values in from that workflow. Maybe something happens in the Markdown workflow that is information that we specifically want to pass into this one. Things like this. Again, with the Kubernetes decorator, a new decorator here called @card. This is a way to kind of do some experiment tracking to visualize data in Matplotlib charts or plot with Plotly or Altair, whatever your favorite framework is. Many other things you can do too, like you can make kind of different tables, represent different widgets inside of whatever sort of like experiment tracking dashboard you want to compose, really. And then the final one that we're going to see is the Pinecone vector indexer workflow. This one's also trigger on finish with the data table processor, as we discussed. And then just kind of furthering the dependency management story, we're using another Docker image, but this time a much meatier Docker image, because this one needs to have GPU dependencies and it needs to have all the transformers machinery built into it. So we might request an instance with more memory on it, more CPUs and or GPU. And then we can easily just swap in and out Docker images like this is a big superpower of Metaflow. Cool. So now like we're kind of getting into like a little bit more of the conceptual layer here, and I think it'd be a good time to just like actually run some code and get
Let's do it.
Running. All right. So I'm going to expand this thing again. And when we open up the sandbox and go to lesson 5, we'll see the full workflow with the code actually written in.
And maybe I'll just add one word about Argo. Argo is a way that we schedule or deploy machine learning workflows. If you've used something like AWS step functions, maybe that's a point of comparison here. But essentially what Argo allows us to do, and maybe you can add a bit more color to this, Eddie, is in terms of productionizing machine learning models, we want to make sure that when I close my laptop at the end of the day and go and have dinner with my family, that we have it running somewhere external to my laptop. And that's something that Argo allows us to do, right, Eddie?
Yeah, that's right. That's right, Hugo. So I'm gonna go ahead and open up the terminal here. And now this is going to be, I'm actually just going to type the command out. These buttons are kind of like automating the process, but I think it's more illustrative to actually just type it out. So we have the flow.py inside. So
it's Python, then the name of the flow and the path to the flow.
Right, which this is just a Python script. So that's the name of the script that we see visualized here. And then to actually deploy this workflow, you type Argo workflows and create. Make this terminal a little bit bigger here. So you see it looks somewhat similar to when we just run the workflow directly. Deploying to Argo workflows. then we get a bunch of interesting information from Metaflow, which I won't really go too deep into detail, but like there's a whole machinery around namespaces and production branches and things that afford like A/B testing, multi-arm bandit testing, these sorts of things in your actual production system. So you can have side-by-side deployments is really the upshot there. Cool. Now let's keep moving. The second one that we want to deploy, let's make this a bit smaller, is the same exact pattern. So looking through this, we see a bunch of like Seaborn, matplotlib code, see a bunch more parameters for our data processing stuff. Then the thing that we're going to look at in a little bit is this at card. So let's just go ahead and get this stuff running. So we have Argo workflows and then create and that's good. Oops.
Wait, we're creating another flow now? Sorry, is that?
Yeah, we're deploying the second flow. So we deployed that first markdown chunker one, and now this one we're deploying is the data processing one.
But weren't we going to have one trigger the other, or?
Exactly. Yeah. So this second one has the at trigger on finish decorator.
Right. So deploying it isn't running it, is what I'm hearing, right?
Correct. So
Yes.
when I say deploy, I'm running this create command. Now, if we wanted to just trigger this thing that's already on Argo, we could just replace create with trigger, and that would do what you're suggesting.
Yep.
Cool. Now let's deploy the third one, and hopefully, if the demo gods are kind to us today, we'll just get this like end to end, all three of them running after just running one trigger command is the idea. Now there's one thing that I left blank up here because I didn't want to put it in a GitHub repository. We'll again do the super hack of just pasting my Pinecone key. But of course, actually, I should show you this instead of just saying it. Metaflow has this feature called secrets that if you're cringing at the fact that I'm doing this, you should check this out because this is the real way in a production system that you approach.
Yeah, and I'm not cringing. I'm totally cool if you do it. We just got to tell people about secrets and environment variables, and also you got to delete that key afterwards.
Well, I just get nervous that I'm suggesting like absolutely terrible people.
The thing that's making me most nervous now is your battery level, dude.
Oh yeah. Well, it's gonna be a buzzer beater. We might have to end the call early on the fine tuning part.
It's like the episode of Seinfeld where Kramer's like going below zero on the gas tank.
Yeah, dude, this is my way. Okay, so our last Argo workflows creates in section 6, the Pinecone indexer.
And we're gonna look at the Argo UI or something like that as well, or
yeah. So let's I'm gonna get the workflow running and then we'll click into the UI.
Well, I just thought it may be interesting to see that it's created but not deployed yet.
Oh, sure. Good idea. Good idea. So I actually just opened up the Metaflow UI, which is connected to Argo. And soon, by the way, this Metaflow UI will be a complete superset of the features in Argo UI. So just point of order. But it's not in the current sandbox edition of the Metaflow UI. So to Hugo's point, we don't see any workflows running in Argo right now.
But we should see them created. Yeah, exactly.
These things that Argo calls workflow templates. So this is kind of like what Metaflow is like, kind of sort of compiling the DAG that we wrote in our Python code into Argo's language of these workflow templates, which we can click into them and then we can specifically see what I'm talking about. Like these are, for people familiar with Argo, these are like the familiar YAML monstrosities that you would run into.
Pardon me.
Okay, cool. So again, what we want to do, trigger this markdown chunker thing. That should have automatically triggered the data processor, should automatically trigger our Pinecone indexer. Let's do it. So now in order to do this, we have basically the same command that we ran before. So let's find our section 4 command. And all we should need to do is take away create and write trigger.
Incredible.
And we'll see. Great. Okay, so we get this helpful printout to the Metaflow UI. But to Hugo's point, we want to let's just look in Argo because it'll be a little bit more responsive right now. So we see that this first workflow is triggered.
Mm-hmm.
Kind of like watch
And
what's
this will be the
happening.
DAG of the workflow. So that's the start step.
Exactly. Exactly.
Very cool.
Well, while we're waiting on this, Hugo, because it might take a few minutes, is a bit of a product plug. But for anybody who's still watching this video, I feel totally okay doing that. Have you seen the visualizations of these DAGs on the Outer Bounds platform recently, with all the work that's been going on there on the front end side of things?
Not recently. Do you want to show me?
Oh man, super exciting. I don't think I have a great example loaded up. Maybe we should do this. We should actually do a full video on that sometime, I
Let's
think,
do
like
it.
comparing to Argo. Like, because like there's a bunch of cool stuff that's now being like consumed into the Metaflow UI that
Yeah.
is like equivalent to what we're looking at now.
Amazing.
Um,
Well, watch this space, everyone.
yes, watch this space. Watch this space. Consider Outer Bounds platform.
So the other thing is we've got a few more slides to show, and then we're going to talk about, I wonder whether just coming back to make sure that this is executed correctly after going through the rest of the workshop would be the way to go.
Yeah, we can definitely go ahead and do that. Do you want to look at the fine-tuning code right away, or should we go back to the slides, do you think?
I'll take your lead, Eddie.
Let's do it, man. Let's just go quickly through the slides. They tell the story a little bit, and then we can pop into the fine-tuning code and look at
Right.
more Hugging APIs.
And this is the last part of the workshop as well.
Yes, yes. And this part's going to be a little hands-off. Like we'll do full-on fine-tuning workshops in the future where
Yep.
this is very hand-wavy, to be honest. Cool. So fully custom LLM now. We're like changing the dynamic of this picture by making everything dark purple. Where what we mean is basically like if you have enough relevant data and you have enough compute capacity, you can make your own model, just do the pre-training part yourself. And the idea is that hopefully if you had enough relevant data that's within the distribution you care about when your users are going to be interacting with the model and your product, that would produce the highest quality of relevance responses. Now, in reality, like getting that much data and training a model that size, there's only a few organizations in the world that can do it. And they're training on data sets that are like the entire internet. So it's like kind of subject or like suspect, in my opinion, to say that that's going to be super relevant to anyone when it's that general. It's almost a built-in trade-off. Now there's this other world of like fine tuning where it's like you have a data set, maybe your data set is quite a bit bigger. It's like 5 to 10 times bigger, or maybe even a couple orders of magnitude bigger than the kind of data sets we're talking about with RAG. Or maybe not. Maybe some models like you don't need that much data to do fine tuning. It's really a case by case basis. That's worth studying as a data scientist if you're into this stuff these days. But what you can do is you can actually keep training the LLM. So you're not pre-training, you're taking like a fork or a transfer learning. This is like a variation on transfer learning. You're taking a fork of the model's state and you're saying like, okay, now here's a new data set. Maybe it has a little bit of different shape, or there's like this trend called instruction tuning where you format the like labeled examples that you give the LLM very specifically. And then you use that to continue training the model. So you're actually updating the weights, the parameters of the neural network. Of course, you could also combine this with RAG. So there's like a lot of interesting research around this. I've even seen like RAG being combined into pre-training as like a recent project from NVIDIA. So there's like a whole bunch of different combinations is the point. But the core idea of what we were talking about here is more this case of fine tuning, where it's like, I actually want to change this blob and make it more dark purple by training on my data, training on a specific shape of data that I think is relevant to our apps and use cases, things like this. So how do we actually do this? There's a ton of good examples on the internet these days. But one way is you can define your model scripts. So this is not too different from a Google Colab notebook I found on the internet. Just like slight refactoring and a little bit of like adding a little extra optimizations on it. It should be runnable on a single V100 if you have a V100 GPU. And what it's doing is fine tuning a QLoRa of the 7 billion parameter Llama 2 model. So that was a bunch of jargon. I think maybe we should talk about Llama a little bit, Hugo? Do you want to like say a few things about kind of the Llama model family or anything come to mind there?
Well, yeah, I mean, a short introduction to everything you just said is Llama's a family that was open sourced by Meta, AI, pretty hefty, big models. I mean, there's a range. But did you say what? Did you say 7B?
Yeah, this one's the small one. The 7B
Yeah.
is the
So,
small.
but it's still big, right?
It's
And
still yeah.
and so, then what Laura does, it's a form of dimensionality reduction. It uses linear algebra essentially to 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 reduce the size of it in very clear ways. The clever ways, sorry. The Q is quantized. I which is a technical detail I don't think we need to get into at the moment. But that's kind of, I suppose, my very TLDR on what like Q Laura on Llama 7B, Llama 2 7B would mean or something. Is there anything else you'd add to that?
No, I think that's great. So like in addition to like adding a little bit of stuff from the collab notebook I found is like the framework
But
where you
also,
can
I'm sorry, yeah, to your point though, even though we have a small model and we're reducing it even more, we still need GPUs, right? So
yeah, right. Like this is just not this one's not very feasible to run on a CPU. It would be like it would take way too long for the model to learn anything for that to be really worth your time or honestly it might even be more expensive because you need the
yeah.
computer to be running long. Okay, anyways, basically what's going on here is we're sort of refactoring our custom data set. We're pulling this nice instruction tuning data set that the Databricks team put together called Dolly 15K.
Mm.
And we're kind of repackaging it in a slightly different way. This is what I mean when I was saying like you can change the shape of how the model looks to continue its responses by fine tuning. So what you can do is kind of like unpack the data in a specific format that's like how you would want the model to respond at runtime. And then you can kind of curate your fine-tuning data set to be in a shape like this. And it sort of just directs the model about how to respond to things. Like this could be another good use case of like, I want this specific structure only as the output of my data. You just make a really good labeled instruction tuning data set like this could work. What else is interesting here? We see the same API for importing our model. So just like we were doing before in the tinier model use case, like just write in your sandbox notebook with no GPUs or anything. It's the same thing. Use this from pre-trained API. We have our quantization config, and then we're just picking a specific flavor of the Llama model. A few other Hugging Face bells and whistles here. Of course, there's the tokenizer piece. And then the API that we're choosing to use is the sort of the highest level API for model training in Hugging Face is this object called the trainer, which takes in another object called training arguments. And this is where we specify a lot of stuff like how to use the GPUs, like kind of what way do you accumulate gradients. You pass in an optimizer so you can kind of like get into this like more like PyTorch layer as well in the trainer arguments. But there's a lot of stuff going on here. And then it's a simple trainer.train. Now, what the kind of the interesting thing, like story-wise here, like we won't really go too much into the code, but we're running this whole script inside of a Metaflow workflow. And one of the reasons we're doing that is because then we can take this model after it's been trained, zip up the whole resulting QLoRa and push it to S3. And Metaflow makes this very easy to kind of like wire this up when we're running it inside of our workflow. And like specifically, like look at how a few lines of code is inside of our Metaflow structure, where we're using the @Kubernetes decorator and the @PyPy decorator that Hugo mentioned earlier. And yeah, we're just kind of making it all happen so that we can then unpack that model on the server and actually run this on a Triton inference server in this case, is what the example shows here. Super high level introduction to the fine tuning and serving aspect of this workshop. Hugo, I think we should probably do a full workshop just on probably each of those pieces independently at some point.
I was just going to say that. And the reason we've decoupled it like that is all the code we've run so far, you've been able to do in the sandbox, and with relatively limited compute and time. Whereas this, you'd need pretty significant hardware as well. So, that's why we wanted to do it this way. But hey, so it looks like we're going back to the Argo workflows.
Yeah, quickly before my battery actually dies, we can see that this first workflow ran. We can go back and see that our second workflow also ran to completion, again, automatically triggered. And our third workflow is now in flight. It finished the start process. Right now, it's kind of doing the heavy compute step, which is actually computing the embeddings and all the Metaflow documentation. And then it's going to push those into the Pinecone index. So that pretty much completes the story, and we're out of slides and out of code in the sandbox so far. And any thoughts, Hugo, to wrap up the session?
Look, I'd actually just like go back. I'm going to share my screen again and just go back to our can you see my slides? Our slides?
Yeah, I'm gonna quickly move and just make sure I can go get a charger before my thing dies as you're doing this.
Sure. What I wanted to do is just go back to when we talked about, just to remind you everything we've done, and if you coded along everything you did, which, you know, everyone should be super congratulated. You've learned and played around with hitting LLM APIs. You've gone through and thought through with us how you can be more flexible with open source software models. Thinking about RAGs, had a great ragathon, and thinking about better relevancy there, going through the Metaflow docs, which was super fun. Then productionizing RAGs, then also going through, this is the code we didn't execute, but going through fine-tuning a custom LLM. So all in just over a couple of hours, you know, and if you did this at 1.5x under a couple of hours, you've managed to learn a huge amount about the space. As I said, in the description, we'll put the link to our Slack community where we love chatting about all of this type of stuff. Very much welcome feedback. Anything else you'd like to see in the sandbox, we'd love to show you and produce at some point as well. But I think with that, that's a really nice note to wrap up on. Eddie, what do you think?
Sounds great. It was super fun, Hugo. We should definitely do this more often.
That was an incredible amount of fun, and thank you all for watching and sticking around until the end. And we'll see you on Slack. All right, ciao.
Yeah.